Hello, I am Dr. K.S. Badarinarayan, the principal of MS Engineering College. I invite you for a discussion on sequencing problems. Generally, we deal with n jobs and 2 machine problems and n jobs with 3 machine problems and 2 jobs and m machine problems. So in this video, we are going to discuss all these 3 cases. So in the sequencing, what we generally face the problems are, we have to find out the sequence of the jobs to be processed on the machines. So here we have only the 2 machines, machine A and the machine B. And if you look at, I have considered 5 jobs, job 1 to job 5 with different processing times. For example, on the machine A, job 1 takes 3 minutes and machine B, job 1 takes 6 minutes. So the times are going to vary depending upon the different types of operations that are going to be performed. We also have the n jobs and the 3 machines problem, in which we have the sequence of operations is also defined, like it will be in the order of A, B, C, and the times for which the different jobs are also indicated in the particular slide. We also have a 2 job and m machine problem, which is going to be solved by graphical method. So generally we have certain assumptions when we are going to solve the sequencing problems, that only one job can be processed on a given machine at a time, and the time taken for the jobs in moving from one machine to another is very negligible and is taken equal to 0, and all the jobs are known and are ready for processing. Each job once started on a machine is to be performed up to the completion of that machine, and processing times are given and do not change. The processing times on different machines are independent of the order of the jobs. So the following assumptions are made, and that's going to be considered while we are doing the sequencing problem. We have the Johnson's algorithm in which which we are going to consider for solving the n jobs and 2 machines. So what we do is we examine the AIs and BIs, that is the processing times for processing the jobs on these machines A and B. We find out the minimum of AI BIs, and if the minimum be AK, let us say for some value of I equal to K, we do the kth job first of all. If the minimum will be BR, that is for I is equal to R, we do the rth job last of all. When there is a tie in selecting the minimum processing time, then there may be 3 situations or the solutions we are going to have. If the equal minimum values occur only for the machine A, select the job with the larger processing time in B for placing the jobs in the sequence first. If the equal minimum values occur only for the machine B, select the job with the larger processing time in A, placing the job sequence in the last. So if there are equal minimum values, one for each machine, then place the job in the machine A first and the one in the machine B last. So cross out the jobs already assigned and repeat the steps 1 to 3, arrange the jobs next to first or next to last until all the jobs are assigned. Now don't worry about these steps, which will be very easy, and you will be understanding by the methodology that what we are going to follow. So now let's take a simple problem in which you have n jobs and 2 machines. We are going to have 5 jobs and 2 machines, and the processing times in hours is given as below. Now when we look at the jobs and the machines, we just form a box, just a box like this, to write down the sequence of the jobs, right? So a box we make and try to fix the jobs here. Now if you look at this particular job, has got 2 units of time, that's, let's say here 2 hours or 2 minutes, whatever the units we are going to fix it. Now the 2 that appears or that exists for the machine B, so therefore this job 2 we are going to place it here. That means since this particular time minimum is occurring for the machine B, so that will be placed in the last, and we delete that particular job. So next, if you look at for the job 1 on the machine A, that is minimum is 3. So therefore that occurs for machine A, the sequence starts from this end, the sequence starts from this end. Therefore we write job 1 there and we delete that particular job. Similarly, the next minimum occurs for job 4 on machine B, that is 3 units of time. So we fix the job 4 here in the box and delete job 4. Next minimum is 4 for the machine A, so therefore the job 3 comes next to job 1. So we delete that particular job. And the next job is the last job, so therefore the job 5 is going to be fixed in the middle. So like this we get the sequence of the jobs to be performed. So the sequence of the jobs to be performed is 1, 3, 5, 4, 2. Now what we do is we take the sequence 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and tabulate in the table, that is 1, 3, 5, 4, 2, and we consider the machines A and B. Now for the sequence 1, the starting time is 0, and what is the time that's going to be taken for the job 1 on machine A, that is 3. So 0 plus 3. Now the next, if the job has to be performed, that is a third job has to be performed A, means it has to start at 3. So what is the time that's going to be taken for the third job? The third job for machine A, it is 4. So it is 3 plus 4 is equal to 7. Next, the fifth job. So 7 becomes the input time and fifth job is going to take 7 units of time. So 7 plus 7, it becomes 14. The next input time for the job 4 becomes 14. Now how much that time 4 is going to take for A, that is 5. So 14 plus 5, 19. The next input time for the second job is 19. The second job on machine A is going to take 7. So 19 plus 7 is 26. That's how we compute the times for the machine A. Now let's take for the machine B. Now if you look at the job 1 is getting processed on machine A up to 3, therefore on the B machine 1 cannot start off until 3. So therefore there will be an idle time of 3 units of time here. So it starts with 3, and for machine B, job 1 takes 6 hours. So therefore 6 units of time, that is 3 plus 6, 9. So once it completes job 1, it is going to start off at 9. So again the third job on machine B, so 7. So it is 9 plus 7, 16. Now again it's 16. So the fifth job on machine B is 4. So 16 plus 4, 20. Next is 20. 20 plus fourth job on machine B, that is 3. So 20 plus 3. Next, if you look at here, so even though the job 4 has been completed on 23 units of time, it cannot start off because still job 2 is engaged on machine A. Therefore, after the completion of job 2 on machine A, machine B can engage the job 2. So therefore it has to wait up to 26. So 26 plus the time taken for the job 2 on machine B is 2. So this 26 plus 2 will be equal to 28. So that's how we compute the processing times for the jobs to be completed on A and B. The total processing time will be equal to 28 units of time, and the idle time on machine A will be 2. That is, it is going to complete at 26 units of time, but the total processing time is 28. So therefore 28 minus 2, 26 will be equal to 2 units. And if you look at the idle time for the machine B, initial beginning we have got 3 hours of delay, that is until this particular time you cannot start up, so 3 units of time here. And if you look at here, that's 23 and 26 is going to start up. So 3 units of time here. So it will be 3 plus 3, 6 units of time the machine B will be idle. And that's how we are going to solve the n job 2 machines problem. Now if I put all the timings on a time chart, so this is how it looks like. This is how it looks like, and the red line, red area indicates the idle time for the machine A here, and the idle times for machine B here, and beginning and in the end you will have idle time. Now let's consider the next n job 3 machine problem. N job 3 machine problem. So when you have got 3 machine problem, what we do is we generally convert this n job 3 machine problem into a 2 job problem. Now how do we convert that to 2 machine problem is the crux of this particular problem. So in this, what we do is generally we identify for a condition, and if this condition is satisfied, we are going to convert into a 3 machine problem into a 2 machine problem. So what is the condition? The condition is we find out the minimum processing time for the first machine A, and we find out the minimum time for the last machine, that is here we have C machine, A machine, B machine, C machine. So A machine we find out the minimum and the maximum for the middle machine and the minimum for the last machine, that is the C machine. Now if you observe the relationship, the minimum of Cij or Ci is greater than or equal to maximum of Bi. That means in the middle column, whatever the maximum is there, we check out the minimums for the A machine and the C machine, compare with it. If the minimum of Cij is greater than or equal to maximum of Bi, then we can convert this problem into a 2 fictitious machines called G and H. So where the times of machine A and machine B are added to get the times for the G fictitious machine. The times of B and C are added to get the times for the fictitious machine H. And now that's what we have depicted in this particular table. That is 3 plus 8 is equal to 11 for the first job. For the second job is 12 plus 6 is equal to 18, so on. So we get the time for the G machine. Next, we add the times of B machine and time for B machine and time for C machine to get the time for H machine. That is 8 plus 13 is equal to 21 and so on. So now we get convert this problem into 2 machine problem, that is G and H. This conversion we are only doing to get the sequence. So in this particular table, if you look at, the minimum occurs for the job 4 on the G machine. So therefore we start in this particular direction, that is for G. If the minimum occurs, we start writing in this direction, we putting the jobs in this particular direction. If for H the minimum occurs, we are going to start the jobs in this particular direction. So for the fourth job we have the minimum 8, therefore we are going to write that fourth here, fourth job there. So next, if you look at, the minimum is 9 and that occurs for the third job. So therefore we write that particular third job here, right? So next, minimum is 11 for the job 1 as well as job 5 for the H machine. That means we write 1 here, 1 here, and so we write 1 here, and the next job is fifth job we are going to write here. Okay, so the next last job that you are going to have is the sixth job, that is for the G machine. So we are going to write that particular job here. So that's how we are going to get the sequence 4 3 1 6 2 5. So once we get the sequence, we roll back to 3 machine problem only. We roll back to 3 machine problem. That means we just convert into 2 machine problem in order to get the sequence. Now in this particular, I had just written this particular table to easily identify what are the times it's going to take. So I just write the sequence, that is the fourth sequence is 4, 3, 1, 6, 2, 5. So I start off with the turning operation. The first it's going to start off 0. For the fourth job, on machine A, it's going to take 2 units. So therefore it's 0 plus 2. Then it's going to start the third job on machine A at 2, and the time for the third job is going to be 5. Therefore 2 plus 5 is equal to 7. So again it's going to be 7 for the job 1. So job 1 on A is going to take 3. So that is 7 plus 3 is equal to 10. So that's how I'm going to calculate the completion time for the job 1. Similarly, as I explained in the previous example, we compute the processing time for the machine B also, and processing times for C also is computed. The total processing time is turns out to be 77 units of time. Idle time of the machine A, now if you look at the idle time of the machine A, it starts at 0, 2, 2, 7, 7, 10, 10 and 21, 21, 20, 33, 33, 42. So it's continuously working up to 42. But the end processing time is 77. So 77 minus 42 is 35 units of idle time for the machine A. Similarly, we calculate the idle time for machine B and machine C. If you look at now, simple, machine C has to start off at the end of 8th time only. So therefore, the idle time will be for machine C will be 8, and nowhere again there is no idle time. So therefore, idle time for C is 8. So similarly, we calculate for B, it is 49 units. Now this is how we compute the timings, the processing times and idle times for a 3 machine problem. So next we have a 2 jobs and M machine problem. So here in this simple example, I have considered a job 1, job 2 with a sequence A, B, C, D, E on for job 1, 2, 3, 4, 6, 2 are the processing times. For job 2, we have this different sequence C, A, D, E, B with the processing times 4, 5, 3 to 6. Now with this particular thing, how do we proceed for the problem? Solving the problem. Now what we do is, in the graphical method, we go for a graph. That means construction of the graph. So in which we take the x-axis and assign to job 1, and y-axis we assign to job 2. So we make a convenient markings or the scaling on the x-axis as well as for the y-axis. So we start noting down or writing down what are the times and the sequence of the jobs. Now if you look at for the job 1, we have the sequence of the jobs A, B, C, D, E, and for the job 2 we have the sequence C, A, D, E, B. So the same sequence of machine are entered here and also here with their processing times. For example, A takes for the job 1 2 units of time. Similarly, B takes another 3 units of time. C takes another 2 plus 2 plus 1, 5 units of time. So like that, whatever the time these jobs are going to, the machine job is going to take on the different machines is also identified and marked accordingly. So if you look at now, if the job 1 has to be completed on all these machines, it's going to take 17 units of time. Similarly, for the job 2, if it has to be completed on all the machines, it's going to take 20 units of time. So we note down or we mark all the jobs with the corresponding time it is going to take on these machines. We just mark that and get this particular graph ready for our processing. So in this next step, what we are going to do is we are going to mark the intersection zones. See, for example, job 1 on machine A, it takes 2 units of time, and job 2 on machine A, it's going to take 5 units of time. So you will have a rectangle 2 by 5 units. So 2 by 5 rectangle we get, and we just mark this, with a different color, and this is called the A machine, where we are going to mark like this. Similarly, the markings for or the intersection zones for different machines are written. So for the B machine, again it starts with 3 units of time here, and you will have 6 units of time here. That means 6 units of time are going to take on the machine B, and 3 units are going to be taken on for the job 1 on machine B. So we mark that particular B. Similarly, C and D and E intersection zones are marked. Now, how does this marking of these intersection zones is going to help us, and what is the significance of this? See, now what we are going to do is, if any line is written, so if you are going to write a horizontal line, the horizontal line indicates that there is a progress for the job 1. So any movement of line, or what line we are going to draw in this direction, means the job is getting processed, or the work is getting processed on the job 1. A horizontal line indicates that the job is getting processed on the work is getting processed on job 1. Now if I am writing a vertical line, it means that the work is getting progressed on job 2. Suppose simultaneously if I have to start off, that means I have to take a 45-degree line. So if I write a 45-degree line, it means that the job 1 as well as job 2 is getting processed on same time. So we are interested in writing down the 45-degree line or horizontal line or vertical line, and see that finally we are going to complete all the activities for the job 1 and job 2. Right. So now how we are going to write these lines? So as I said, the horizontal line progress on job 1, vertical line progress on job 2, 45 degrees progress on job 1 and job 2. Now if you look at, I can start writing a 45-degree line, start from 0, a 45-degree line up to 9 by 9 square. So this is a 9 by 9 square. So up to 9 by 9 square I can write a 45-degree line. So what does it mean? It means that job 1 and job 2 both can be processed simultaneously without any idle time. That means job 1 can be done on machine A, machine B and machine C continuously. Similarly, job 2 can be done on machine C, machine A continuously up to 9 units of time. So that's what it means when I write a 45-degree line. Now here if you see 45-degree line we have written, and that comes to the corner of this particular D. We cannot further progress and start writing a 45-degree line because we have got an intersection zone. So it prevents the writing of a 45-degree line. Now I have got an option either to go in a horizontal way or in a vertical way. So I choose to go for a vertical way because it's going to be the minimum time, right? So if I look at now here, I got again another 3 units of time, and when I write another line, so it is 3 units, and that's idle time for the job 1. So vertical line indicates that there's an idle time for the job 1 and the work is getting processed. The job 2 is getting processed on the machine D, right? So the time taken here, it will be 9 plus 3 up to here, this particular point, the time will be 12. Now next, what is the alternative? Next, can I write another 45-degree line? Yes. So I can write one more 45-degree line from 12 here to the last point, that is 20. That means if I draw a line like this, I will be in a position to complete both job 1 and job 2 and arrive at this particular point. So it indicates that the total time that's going to be taken for us to complete both the activities is 20 units of time, right? With an idle time of 3 units of time for the job 1, and the final result what we are going to have is the total processing time is 20 units of time, idle time on job 1 is 3 units, and the idle time for job 2 is 0. That means we do not have any idle time for the job 2. Thank you for watching. Please subscribe to MSEC channel.